Class 12 student, class 12 student, that is your chapter is composition function, composition of functions, composition of functions. Your first chapter is composition of functions. So here your exercise 1.3. Your question number 1 is, let f 1 3 4 1 2 5 and G 1 2 5 1 3 be given by f is equal to 1 2 3 5 4 1 and G equal to 1 3 2 3 5 1. We have to write down, that is golf. So here f, it is given, so solution, I am going to direct write the solution, that is golf, that is equal to G of fx, and for x is equal to 1, your x is equal to 1, your fx is 2, so G of fx, when it is 1, your fx is 2, so this comes to be G2, and this is G2. Here see, G2 is equal to 3, so this is 3. Similarly, G of f3, this will be G f3 is f3 is your fx is 5, and your 5 is equal to 1. So again, your G f4, this will be equal to 4 is 1, G1, and your 1 is 3, this is equal to 3. So your golf will be 1 3, then 3 1, and then 4 3. This is your answer. So this is your answer. Now I am going to question number 2. Here question number 2, that is question number 2, let f, g and h be functions. They are functions from a real number to real number. We have to show that your f plus g oh is equal to foh fog, and for g foh and goh, and f dot goh is equal to f of h dot goh. So here solution, here your f function, and your f function, it is given from R to R, and your g function is also given from R to R, and your h function is also given from R to R. So now f plus g this x, this will be we can write as f plus g hx. So here again this is what we call a distributive property, you can say f hx plus g uh, hx. So this is equal to f of hx plus g of hx. So you can say that f of h plus g of h. Now your second part of the question is, that is f dot g oh x. So here this will be f dot g your hx. So this will be f hx dot g hx. So this will be f of hx dot g of hx, and we can write this as f of h dot g of h. We can write this. So this is what we have to prove. Now my next question is that my next question is question number 3, that is we have to find g of f and f of h if first fx is equal to modulus x and gx is equal to modulus 5x minus 2, and my second question is fx is equal to 8x cube and gx, that is equal to x to the power of 1 by 3. Now I am going to do only one for you. You can do the second yourself. That is, let me find the g of fx, that is g fx. Here you see g fx is modulus x, so this is modulus x, and this becomes x for here, so modulus 5 modulus x minus 2, this you. Similarly, you can find for f of gx, this will be f gx, and here you see your gx is modulus 5x minus 2. So this value we have to put here. This value you have to this becomes x, so this x you have to put here. So this modulus 5x minus 2 modulus, this is your answer, because this becomes your x, so you have to put the value of this. Now again for second set, here you say g of fx, this will be g fx, and here your fx is 8x cube, and this value, this becomes x, you are going to put here. So 8x cube the whole to power 1 by 3. So this comes out to be 2 cube. So 2x, this comes out to be 2x. Now this comes out to be 2x, and similarly you can find this fog. So f of gx, this will be f gx, and your this gx is x to the power of 1 by 3. Now you are going to put the value of x in this. So this will be 8 x to the power of 1 by 3 to the power of 3. So this will be 8x. So this is question number 3. Now I am going to question number 5. your question number 5. I'm going to question number 5. Question number 5 is that question number 4. Your question number 4 is that question number 4. Your question number 4 is that if your fx is equal to 4x plus 3 and 6x minus 4, where x is not equal to 2 by 3, we have to show that that f of fx is equal to x for all x not equal to 2 by 3, and we have to find out what is the inverse of f. We have to find out the inverse of f. So here you see solution, that is f of fx that is equal to fx. So this is this is 4x plus 3 by 6x minus 4. Now this becomes x for again this. So when we put the value of 4x plus 3 by 6x minus 4 plus 3 by 6, 4x plus 3, 6x minus 4 minus 4. So here your LCM is 6x minus 4. This is 4x plus 3 plus 3, 6x minus 4, and again here LCM is 6x minus 4. So 4x plus 3 minus 4, 6x minus 4. So this will be, your result will be something like this. This cancels out. 16x plus 12, 3 6 are 18x minus 12, 24x plus 3 6 are 18, minus 24x plus 16. So this comes out to be 12 cancel out. So 18, your 18 plus 16, this will be 34. So this will be 34x, and 24x cancels out, 34. This will be equal to x. So x not equal to 3, because why it is taken in the question. So if you place the value of 2 by 3 here, so 3 2 4, 4 minus 4, 0 not defined, the function becomes not defined. So it has defined that x is not equal to 2. Now I have to find the inverse. Again, now I have to find the inverse of f. So to find the inverse of f, this is fx is equal to, I have fx means fx is equal to 4x plus 3. This fx means this is y is equal to 4x by 3 by 6x minus 4. So this will be y 6x minus 4 is equal to 4x plus 3. So this will be 6xy minus 4y, 4x plus 3. So um, hmm, let this move here and this go there. So 6xy minus 4x is equal to 4y plus 3, and this is x. So 6y minus 4 is equal to 4y plus 3. So your x comes out to be, that is 4y plus 3 by 6y minus 4. So this is your x comes out. We can say that this is a gy function, that is 4x 4y plus 3 by 6y minus 4, and or this is f inverse, or we can also say that f inverse that is equal to 4x plus 3 by f inverse x. This we can also say that f inverse 6x minus 4. We can also say this, we can say this is f inverse gy function, or we can also say f inverse x is equal to this. We can also say this. Now uh, so we can also say this. Now we are going to uh, question number 4. Question number 4, you can do it yourself. This is not so a tough question. Now I'm going to question number 6, that is so that your f such that -1 to 1 to r given by your fx is equal to x x plus 2 is 1 1 function, and we have to find the inverse. We have to find the inverse of the function. We have to find the inverse of the function f such that -1 to 1, that is range f. So here solution, that is let x1 and x2 belongs to -1 1. So here fx1 is equal to fx2. So x1 by x1 plus 2 is equal to x2 by x2 plus 2. Now x1 into x2 plus 2 is equal to x2 into x1 plus 2. So x1 x2 plus 2x1 is equal to x2 x1 plus 2x2. So 2x1 is equal to 2x2 2x2. So x1 is equal to x2. So it is a 1 1 function. It's a 1 1 function. Now I have to find the inverse. So to find the inverse, now I have to find the inverse. So to find the inverse, I'm going to do like this. To find the inverse, that is what I'm going to do. That is fx means y is equal to x by x plus 2. So y into x plus 2 is equal to x. So your xy plus 2y is equal to x. So your 2y is equal to x minus xy. So 2y is equal to x common 1 minus y. So 2y by 1 minus y is equal to x. Here you see uh, uh, this is gy. Now now there is one thing. This is gy. Now there is one thing, that is um, mm, mm, because here this must be between this, it is given, it's okay. So this is your f inverse, and we can write f inverse x is equal to 2x by 1 minus x. We can write like this also for x not equal to 1, that is x cannot be equal to 1. So this is your answer. Now I am going to question number uh, question number your uh, 7. I am to question number 7. Consider that is f such that r to r given by fx is equal to 4x plus 3. So we have to show that f is invertible. We have to show that f is invertible, and we have to find the inverse of f. So solution, we have to prove that it is a 1 and onto function. Then let x1 and x2 belongs to real number, so fx1 is equal to fx2. So 4x1 plus 3 will be 4x2 plus 3. So this will be 4x1 is equal to 4x2. So this will be x1 is equal to x2. So this is a 1 function. This is a 1 function. 1 function. 1 function. And now you take, since real number, you take any value of let us take any value that is -2. It belongs to, that is y equal to -2. It belongs to real number, so -2 is equal to 4x plus 3. So this will be -5 is equal to 4x. So -5 by 4, -5 by 4 is equal to x, and this belongs to real number. So your fx is equal to y, so it is an onto function. It's an onto function. So uh, it is invertible, therefore f is invertible. F is invertible. Now we have to find the inverse. So to find the inverse, we have to find the inverse. So to find the inverse, let y is equal to 4x plus 3. So y minus 3 by 4 is equal to x. This is your gy, and this is your f inverse. So here you can write that, or you can write that f inverse x is equal to x minus 3 by 4. X minus 3 by 4. So this is your answer. Now I am going to another question, that is question number 8. Question number 8. Question number 8. So your question number 8, consider, you have to consider f are positive reals number to this for infinity, given by your fx is equal to x square plus 4, and you have to show that f is invertible. We have to show that f is invertible. F is invertible with the inverse f inverse f is invertible, and your f inverse f inverse y, that is equal to root y minus 4, where your r plus is the set of all non-negative real numbers, all non-negative real numbers. This is f inverse y. You have to find out, and we have to also show that this is invertible. So there are two ways which you can show that this is invertible. Solution, that is, you can show this there are two ways. So first you can prove that it is 1 1 and onto function. So let your x1 and x2 belongs to R, therefore fx1 is equal to fx2. So x1 square plus 4 is equal to x2 square plus 4. So here you see that x1 square is equal to x2 square, so you can say that x1 is equal to x2. So it is a 1 1 function, 1 1 function. And again you take any domain, that is 4 to infinity. Let me take this y is equal to 5. So 5 is equal to x square plus 4. So 1 is equal to x square. So your x will be equal to 1, and this belongs to R plus, so it is onto function. So your fx is invertible. Now there is another way you can prove that it is invertible, that is if now your this fx means you can write this y is equal to x square plus 4. So y minus 4 is equal to x square. So this is root y minus 4 is equal to x, and this is your gy. Now you find out gof. This is equal to g of fx. So this will be g. Your fx is this is your fx. This is x square plus 4. And now when you put this is y for this function. When you place here, this will be x square plus 4 minus 4. This will be root x square. This will be x. And now you find fog, that is f of gy. So this will be f your gy, this is gy, root y minus 4. So this will be, you place this value in this x, so this will be root y minus 4 the whole square plus 4 and this will be y minus 4 plus 4, this is y. So your gof is equal to x, and your fog is equal to y. You can say that f is invertible, and your f inverse is your root y minus 4. Now let me go to question number 9. Question number 9. Your question number 9 is consider f r positive to -5 to infinity given by fx is equal to 9x square plus 6x minus 5. You have to show that f is invertible. You have to show that f is invertible with f inverse y. that is equal to root y plus 6 minus 1 by 3. So uh, you can, there is a two way. I'm going to do in the other way, that is let y is equal to 9x square plus 6x minus 5. So 0 is equal to 9x square plus 6x minus 5 minus y. So your 9x square plus 6x, your 5 plus y equal to 0. I'm going to apply the quadratic formula. This will be minus 6 plus minus root plus minus root here, that is b square, that will be 36, minus into minus plus, 4 9 are 36, 5 plus y by 2 9 are 18. So this will be minus 6 plus minus 6, root here 6 36 common, so comes out to be 6. So y plus 6 by 18. So your x is equal to minus 1 plus minus root y plus 6 by 3. Now here you see that since your x equal to minus 1 minus root y plus 6 by 3 does not belongs to r plus, because r plus it is given to you, so your x will be equal to minus 1 plus root y plus 6 by 3. This is your gy. Now what I am going to do is that I am going to find a fog and Goff. So your gy is this, so I am going to find fog and Goff. So your first fog, that is f of gy, this will be equal to f, your gy is root y plus 6 minus 1 by 3. And now I'm going to place, this is x for you, I'm going to place it here. So 9 root y plus 6 minus 1 by 3 the whole square plus 6 root y plus 6 minus 1 by 3 minus 5. So this 9 cancels out, so root y plus 6 minus 1 the whole square, 3 2s are, so 2 root y plus 6 minus 1 minus 5. So a square y plus 6 plus 2 root y plus 6, not plus, this is minus, and then plus 1, and again plus 2 root y plus 6 minus 2 minus 5. So this cancels out, and 6 6 7 7 cancels out, this is equal to y. So your fog is y, and now I am going to find out Goff. I've got fog y, your fog is y. Now I'm going to find Goff, g of f, this is equal to g of fx, and here your fx is this 9x square plus 6x minus 5. I'm going to place the value in, this is y, so this will be equal to 9x square plus 6x minus 5 plus 6 minus 1 by 3, by 3. So this will be 1, so this will be 3 plus 1 the whole square, so this becomes 3x plus 1 the whole square minus 1 by 3. So this will be 3x plus 1 minus 1 by 3, so this comes out to be x. So your Goff is x, and your fog is your y. So this function is invertible. Function is invertible and invertible, and this is gy, that is f inverse. This will be uh, this is root y plus 6 minus 1 by 3. This is your gy. You can do this in another way also. You can prove that this is a 1 function. Then also you can say that it is invertible. You can do it in another way also. That is, you can easily prove that this is a 1 function. You can easily prove that this is a 1 function. So if you can prove, so it is invertible. And you see the value of y. um, you can also prove in other way, that is, it is a 1 function. You can also do like this, that is 1 function. For this, let x1 and x2 belongs to this r plus. So your fx1 is equal to fx2. You can do it like this also. So this becomes 9x1 square plus 6x1 plus 5 is equal to 9x2 square plus 6x2 plus 5. Now here these two are equal, 5 cancel out. So 9x1 square minus 9x2 square plus 6x1 minus 6x2 equal to 0. So here 9 common, x1 square minus x2 square, here 6 common, so x1 minus x2. So here x1 minus x2 common, it is left by 9x1 plus 9x2 plus 6. So here this can never be 0. So this part can never be 0. This is never 0. So x1 minus x2 is equal to 0. So x1 is equal to x2. So you can prove that this is a 1 function. This is a x2. This is a 1 function. And at the same time, you can prove that this is an onto function, because why you can prove this is an onto function. See how you can prove that this is an onto function. You take this y value is -5 greater than -5, since your codomain it is given that your this fx, this codomain is fx, which is greater than equal to -5 and less than infinity is given to you. Therefore you select value of y, any y greater than -5. That is, if you select let me select -4. So this will be equal to 9x square plus 6x minus 5. So this will be equal to 0, is equal to 9x square plus 6x minus 1. Now 9x square plus 6x minus 1 equal to 0. You find the value of x. Minus 6 plus minus root b square, that is 6 square, minus, that will be 4ac, 4 9 are 36, so by 18. So this will be equal to x equal to minus 6 plus minus root 36 plus 36, that is will be 6 root 2 by 18. So your x will be minus 6 plus 6 root 2 by 18. So here you see that x is equal to 6 common, root 2 minus 1 by 18, 2 6 3s are, so x will be equal to, so here your x will be equal to, so here your x will be equal to root 2 minus 1 by 3, and this belongs to r plus, this belongs to r plus. So you can easily say that it is an onto function, it is an onto function. And so your f is invertible. You can say that f is invertible, f is invertible.